Hello everyone, welcome to Mayo Programming Club. Today we will be solving another daily Leetcode challenge, and the challenge name is climbing stairs. So the challenge statement goes like this: you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb the top? Okay, so let's have a look at the constraints also. And here is of the order 45. uh, it ranges from 1 to 45 steps. So how we will be solving this problem? Let's see. First one, what we can do is we can use brute force approach. We can try out every possible combination. And see, count the number of combinations which lead us to exactly on the top. Which lead us exactly on the top. Or say nth stair. Okay, uh, this is one way. So at each step you will be having two choices. uh, Jump two steps by taking two steps at a time, or jump one step. Okay, so these are the two choices you are having, and in total there are n steps. So it will be something like this. So 2 raised to power n. Okay, and it is n is of order 45, as you can see from the constants. Okay, it's mentioned here. So 2 raised to power 45. Let's see what 2 raised to power 45 is. Or let's say not 45, let's see what 2 raised to power 20 is. This is 2 raised to power 20. Okay, now let's see 2 raised to power 30. So this is 2 raised to power 30. How many number of digits? 5 here and 5 here. As you can see, it's about 10 raised to power 10, of order 10 raised to power 10. Okay, so 2 raised to power 45 is very much greater than 10 raised to power 8. So these will be the number of operations that you will be requiring. Let me take it to another slide. 2 raised to power 45, and the comparison was from 10 raised to power 8. So number of operations required by program. Brute force approach. Okay, number of operations required by brute force approach. It will be the order of number of operations. Okay, and it is very much greater than 10 raised to power 8 number of operations limit. Basically what happens is, if the number of operations required by your program exceeds this limit, then you will get a TLE. Exceeds or become equal to it, then you may get a TLE and your solution will not be accepted. So those of you who are new to this concept, I will be providing link of article explaining how the time complexity of accepted solution varies according to input size. Okay, so you can explore this article and then you will be able to understand what this limit is for. Okay, so we have to optimize our solution somehow in order to get it accepted. So let's optimize the solution. Let's say you are having two combinations. Let's say 5 number of steps are there, n is 5. So there is one combination which is having 2 2 1. Let's say there is another combination let's say there is, instead of 5 there is 6 steps, and one is having 2 2 2 triple 2 as the number of steps that we will be taking in each move, and this is combination 1. Now this is combination 2. This is having 2 2 and then 1 1. Okay, so it also sum up to 6. So this is 6. Let me erase and rewrite. So this is 6, and as you can see we are having these first two steps common in these two different combinations. So we are having overlapping subproblems. And we will be doing calculations for them again and again. Same calculations more than once. So we are doing extra work. Okay, so the first property of approach called dynamic programming is satisfied here. Those of you who are new to this dynamic programming approach, I will be providing a link of article describing what dynamic programming is. Okay, so a link will be provided here. So this is property 1 that is to be satisfied in order for you to approach dynamic programming, or see that this problem fits into the category that which is eligible to apply dynamic programming. Okay, it is nothing but optimization over brute force. Let me discuss the second property. And so as you can see, if you are to find out what will be the number of steps required at this particular one, then how could you have ended at this particular step? uh, Either you could have made a two-step jump, and a one-step jump was also possible to arrive at this particular step. So you are having two previous states that are contributing to the current state. Let this be the current state, and these are two previous states. These are previous states. So we can say that solution of bigger problem can be derived from the solutions of, by combining the solutions of smaller problems. Okay, so you can combine the solutions and then you can easily form the solution of bigger problem. What I mean to say is, first of all, this property is called optimal substructure. Then what we mean by this particular property is, let's say you are on the nth step, or say ith step. So the number of ways for the ith step will be, this is your current state, dependent on two previous states. One will be the state one step backwards, that is that you could have ended up on the current state from one previous state or two previous state. So either you could have made a jump from this state and it was a two-step jump and you ended up on this state. Either you could have made a one-step jump and you could have ended on this particular current state. So these are two previous states, two possible previous states. So we are taking contributions of, adding contributions of two possible previous states to the current state. Adding contributions of two possible previous states to current state. Okay, so this is what we are doing here, and we are having a transition equation for our dynamic programming approach. So this is the transition equation, how you will be transitioning from one state to another. Let's take it to another slide. Okay, so this is our transition equation, state transition equation. Now you may ask, what are the states here? States are nothing but the steps or the stairs, and the number of the stair, the number of the stair that we are on. Okay, so this is what the stair is in this particular problem. So at last what we have to do, we have to just return what is the possible way to, number of possible way to reach nth stair. Okay, so we will be building our solution from the very first stair to nth stair, and at last we will be having our answer as a number of ways to reach the nth stair. So let's see the implementation. So this is the implementation. You can rename it number of ways to reach. Okay, and we will call, we will use this data structure to store the results of intermediate state and form the solution of bigger states using them, and avoiding extra work. In case of overlapping subproblems. So this is what dynamic programming is. You store the results for the intermediate states and form the solution of bigger states using the solution of intermediate states, and thus we avoid extra work in case of overlapping subproblems. So this problem was satisfying those two conditions. What were the conditions? One was optimal substructure and other condition was overlapping subproblem. So these two conditions were satisfied by this problem. So we came to know that we can apply dynamic programming here in order to avoid extra work. This is just optimization over brute force. So next what we will be doing to reach the first step, or 0th step, there is only one way, and then we will be building our solution starting from the second step. Okay, and once, what we will do, so this is our current step, current state, and these are our previous states. Let's call them previous state 1, and this one let's call it previous state 2. So what we are doing here is we are adding contribution of previous states to the current state. Okay, and then simply we will be returning a number of ways to reach the nth stair. Okay, so this is how we will be solving this particular problem. If you are still having any doubts or any queries in general, please feel free to ask them in the comment section of the video. I will be more than happy to answer. Thank you for watching. Have a great day ahead. And also, before ending the video, just let me quickly explain what will be the time and space complexities here. So the time complexity will be order of n, since we are doing only one traversal. So time complexity wise it will be order of n, where n here is the number of steps. And space complexity wise it will also be order of n. Okay, n here is the number of steps again. Okay, since we are using this vector, so space complexity is also order of n. So that is it from my side. Thanks again.